let's get started. Just a few reminders. The review for the midterm is tonight at 7 in Evans Hall, and you should come prepared with questions that you have at that midterm. You should all have gotten the midterm essay questions and be working on them now. And the midterm is going to be on Wednesday. And remember again to bring a Scantron and a blue book, maybe more than one blue book, to the exam. Any other questions about the exam? Yeah. Which Scantron? The green Scantron. Yeah. Yeah, a green book is fine. Just a book. Okay. Any other questions? Okay. So since we have the midterm coming up on Wednesday, what I'm going to do is start the section on preschool cognitive development and conceptual development today, and then we'll do the second half of that on Monday, and then we'll just have one next Monday, and then we'll just have one lecture on social development next Wednesday. So we're going to sort of split up cognitive development in between the 2 weeks. Okay, so we're going to start out talking about how it is that preschoolers start to understand the world around them. And we saw from a couple weeks ago, that even infants already understand quite a bit about the world and about the mind. And what I'm going to do today is talk about two aspects of preschoolers' understanding. One of them, their understanding of intuitive or everyday biology. And then I'm going to talk about the role that play has to play in their understanding of what's going on around them, and a little bit about their causal understanding. And then what we'll do on next Monday is talk about preschoolers' understanding of the mind and their understanding of other people. Okay. So let's start out. Some of the background is, as I said, Piaget, who was the great founder of cognitive development, thought that very young children didn't really have much of a causal understanding of the world at all. So he thought that children were pre-causal, egocentric, solipsistic, that they were only paying attention to the superficial perceptual features of the world. They didn't have a kind of deeper, abstract, conceptual understanding of the world. And you can hear echoes of that view in lots of other places and lots of other descriptions of cognitive development in preschoolers. But over the past 20 or 30 years, what we've discovered is that that's the opposite of the truth, that from the time they're very young, children already have a very sophisticated, abstract, conceptual understanding of the world. And I'm going to give you a couple of examples of that today. So the first example I'm going to give is about children's intuitive biology. So children's intuitive biology is their understanding of how living things work. So things like growth and inheritance, illness, death. And again, the conventional wisdom about this was that this was not something that children really understood until well into the school age years. We don't have biology classes until well into the school age years. In the past 15 or 20 years, we've discovered that even very young children seem to understand a lot about biology, and interestingly, also seem to change their understanding of biology, seem to learn a lot about the biological world, even when they're very young, even when they're preschool age. And it's probably no coincidence that even babies are fascinated by animals and plants and objects that are out there in the natural world. So some examples of this kind of, and this understanding is interesting because it's interesting that the children understand a lot about intuitive biology, but it's also interesting because it's a good example of children being able to go beyond just superficial perceptual features of the world to understand the world in a deeper and more conceptual kind of way. Let me give you an example of one of my favorite studies about this. Most of this work has been done, a lot of this work has been done by Susan Gelman, and she has a book in 2003, The Essential Child, that summarizes all this. One of my favorite examples was that she was interested in how children understood what a species was. So how do children understand, say, the difference between cows and pigs? And the kind of superficial idea you might have, say, going back to Piaget, is that children thought that the difference between cows and pigs was just something about the fact that cows moo and pigs oink, and that cows are brown and pigs are pink and so forth. So you might think that children just understood these things in terms of these superficial features. But what Susan did was to ask children questions about which features of an animal, for instance, would be inherited by baby animals, and which ones wouldn't be inherited by baby animals. And what she discovered was that children had quite strong views about which aspects of an animal would be inherited and which ones wouldn't. So, for instance, she asked them these wonderful animal adoption questions. So she said, suppose a bunch of cows decided to adopt some pigs. So the little baby pigs went and they lived with the cows for their whole life, and the cows took care of them, and the cows helped them to grow up. Would those baby pigs have curly tails or not? And would those baby pigs oink or moo? Any intuitions about this in the audience? Well, what the children said was that the baby pigs would continue to have curly tails even if they were raised by cows. But they said that they would moo rather than oink if they were raised by cows. So the children already seem to have an idea that there are some features of an animal, like what its tail is shaped like, that are just part of its inheritance. They're just what it's going to be like. But there are other features of an animal, like the kind of noise that it makes, that can be influenced by its environment. So in a way, it's as if the baby's preschoolers already have a kind of basic idea about nature and nurture. And this is also an interesting example because you can kind of see why the kids ended up with the oink and moo hypothesis. After all, if you look at people, if you had a baby who was adopted by a Japanese-speaking family, they would end up speaking Japanese. But it's a nice example where the children, obviously, it wasn't that the children were saying this because other people around them had said that to them. So no one had ever told the child, yeah, well, if a baby pig was adopted by cows, it would moo instead of oink, given that that's something that we don't actually think is true as adults. But the children already seem to be discriminating between some features that they thought were sort of essential parts of the animal, like the shape of its tail, and then other features that they thought were the result of its nurture and its environment, like whether it oinked or mooed. So there's an example of quite abstract conceptual understanding of biology that you see in place even in 3- and 4-year-old children. And there are a number of other kinds of examples of that. But even though you already see in these very young children this understanding of things like inheritance, so that's an example from inheritance, but using similar kinds of experiments, children, even 3-year-olds, seem to understand things about things like illness and growth. But there also are changes in children's conceptions of biology in the preschool years. So it isn't just that children start out knowing everything there is to know about biology. And one of the really interesting examples of a change in children's understanding of biology is children's understanding of death, a sort of dramatic example. So 3-year-olds aren't terribly perturbed about the concept of death, because 3-year-olds tend to think of death as if it's really a kind of relocation. So they'll say things like, well, grandma died and she's in the ground, or she's in heaven. And if you ask them things like, well, could grandma actually come back again? They'll say, yeah, of course she could come back again. She could come and visit from heaven if she wanted to, or she could come back out of the ground. They don't seem to recognize the sort of irreversible, final, and biological nature of death. So they treat death as if it's like a physical thing, like just moving, just going someplace else, going someplace far away. But when children get to be about 5, still in the preschool years, they start to understand that death is this irreversible biological phenomenon, and that you can't actually come back again. That death involves a kind of permanent ending to something important biological about you. And even though children might continue to say things like, well, grandma's soul is in heaven, they recognize that that's different from actually thinking that grandma's body is continuing to exist. They recognize that grandma's body isn't there anymore, but and that this is this kind of irreversible biological change. And in fact, children often get much more upset when they're about 5 about death because they start to recognize that there's this change where death actually becomes irreversible. Yeah? Well, I'll get to that point in a minute, right? So it does seem as if children, in fact, yeah, I'll get to that point in a minute. It does seem as if children are, when these are children that Virginia Slaughter studied, and even if they didn't actually have relatives who died, there was enough conversation about death in the environment so that they seem to learn these things. But that's a very good question, and we'll get back there in a minute. Was sort of a slightly sad story about this. I had a colleague who came to give a talk, who'd done some of this work, Susan Carey, who came to give a talk about this, and we actually held a talk at my house when my son was about 7 years old. And she had done studies that looked at children with Williams syndrome, which is a particular kind of mental retardation. And one of the things that she found was that even 12 or 13-years-olds with Williams syndrome still continued to have this kind of 3-year-old picture about death as relocation, didn't seem to understand death as being irreversible. And my son, who at that point was just going through serious existential angst about death, turned to me and said, you know, maybe there would be some advantages to actually being developmentally delayed like those Williams syndrome children. So he was actually a little envious of the thought that you could not understand that death was irreversible. And you can show the same kinds of, both the same kinds of early understanding of biology and also changes in understanding of biology if you just look at children's natural speech. And remember when we were talking about methods, I talked about this Child As database, which is just a database of all the spontaneous explanations that, all the spontaneous conversations that children have with their parents. Thousands and thousands and thousands of these utterances that are just spontaneous things that children say when they're talking to their parents. And Henry Wellman and Susan Gelman actually did an analysis of that database looking for biological explanations. What kinds of things did children just spontaneously say about when they were trying to explain biological phenomena like death or illness or growth or inheritance? And what they discovered was that children gave these kinds of explanations, but the kinds of explanations that they gave changed over time. And often, again, as with the case of those experimental studies of inheritance that I talked to you about, the children gave explanations which didn't quite make sense to us, but which seemed to make sense to them. So children would say things like, he needs to eat so he can grow long arms, which is sort of right. I mean, it is true that you need to eat to grow long arms, but it was pretty clear that the child's view was the food kind of came in and then it made your arms grow longer, just as if it was a kind of force that came in and filled out your arms. And in fact, those kind of studies led two Japanese scientists, Hatano and Inagaki, to suggest that towards the end of the preschool period, so between 3 and 5, there was this kind of shift in children's understanding of biology. So even though they had some abstract understanding of biology even when they were 3, around 5, they started to have this kind of single coherent theory of how biology worked. And it's interesting because that theory was different from what we think of as being our adult theory of how biology works, but it was also different from what the 3-year-olds thought about how biology worked. And basically, the way that Hatano and Inagaki describe this is it's a kind of vitalist theory of biology. So what children seem to start thinking when they're about 5 is there's a single vital force, a kind of life force, an élan vital, very much like the Chinese concept of qi. There's one force that goes through your body, and if that force is in good shape, then you're healthy and you're alive and you grow, and if there's something wrong with that force, then you get sick and you dwindle, and eventually when the force goes away, you die. And when Inagaki and Hatano looked both at children's explanations and then at their responses across a wide variety of experiments, sort of like that Susan Gelman experiment that I talked about, they showed this change in this kind of very broad-ranging, coherent conception of what biology is like. And that change in children's conception of death went along with this change to this new vitalist theory of biology. So once you start thinking about this single thing, the life force that kept you alive, then you start to understand that death was about not having that life force anymore, having that life force go away. And I think it's kind of an interesting example because even though as educated adults our notion of biology isn't this kind of vitalist notion, we still find it sort of appealing. So you'll hear people say things like, well, you need to eat a lot because you need a lot more energy, or, you know, I'm really low energy today, and there was a lot of good energy there, and then that good energy vibe is part of why I managed to hold off that cold. So we talk as if we're still sort of vitalists, even though we don't actually believe in vitalism anymore. A really interesting experiment that came out of this, so you might then ask the question, where does the question that you were asking, well, where does this idea come from? If children are developing this idea about a single unified biological theory, this kind of vitalist theory, what kind of experiences do they have that lead them to develop that theory? Or maybe they don't have experiences that lead them to develop it, maybe it just matures or something when they're 5. And a very elegant series of experiments, Devin Dean and John Coley, looked at children who were growing up in Menominee Indian reservations in Michigan. And in general, these children are very disadvantaged on lots of dimensions. They have very low SES, they're more likely to drop out of school, but they have much more experience of the natural world than the children in the urban advantaged preschools do, because these are children who are growing up in a society where people are still hunting and fishing, and children are spending a lot of time out in the natural world and dealing with plants and animals. And what they discovered was that when you looked at this kind of vitalist theory of biology, the Menominee children actually were advanced compared to the children in the urban preschools. And in fact, if you looked at even just the children's science scores until they were in 2nd or 3rd grade, they did better on tests of science than the privileged children in the urban preschools did. The sad thing was that after about 3rd grade, that reversed, and the children didn't do as well anymore, and then eventually by the time the children were in high school, they were not doing nearly as well. But it seemed as if this early experience of actually seeing of getting a chance to see the natural world had made a real difference to the children's understanding of intuitive biology. Yeah. Oh, sorry, SES. SES is socioeconomic status. So these are basically very poor children on this reservation, and not just poor in terms of not having money, but they're likely to they're often in social dysfunction, they're isolated, all those other kinds of measures of just sort of how privileged you are. Basically, that's SES. And the thought was that what happened was that their initial boost came from the fact that they had all of these experiences of what the now again. I mean, when I say that, in some ways, of course, these kids weren't impoverished at all. What these studies show is in some ways they were living in a very enriched environment when it came to understanding the natural world. And the thought is that to begin with, their understanding of the natural world was giving them this boost in science. But then, especially as you got into older grades and the kind of science you were doing was further and further removed from your actual experience of the natural world, then the other problems and disadvantages started to kick in. I mean, that's not proved. That's just sort of the idea that people had. So the idea was you started out understanding more about the natural world because you had more experience with the natural world. And especially with these kind of 5-year-old understandings of biology, you saw those coming in empirically earlier in the children from the Indian reservations. But that wasn't enough to boost them all the way through to high school science. Yeah?
Question. What is wrong with the biology theory, child's version of biology theory versus what else is
Right. So if you think about adult biological theory, we don't think there's just one force that's responsible for growth and illness and death. So what we really think is that the body's a mechanical system and it operates according to these particular mechanical causal principles, and then there's all sorts of things that can go wrong or can go right depending on how that mechanical causal system actually works. So we think that the reason why we die isn't because there's this vital life force that escapes from us. We think that a whole bunch of physical systems that have to work together, like our heart beating or our blood coming to our brain, that just stops working, and when that stops working, the whole body stops working. Sort of the way you think about a machine, say that you think, okay, well, when the machine gets broken, it doesn't work, but it's not that you think there's some vital force in the machine that's making it work that isn't there when the machine gets broken. That's kind of the difference. Yeah? Another question?
I'm so confused. Are these studies of positive non-intuitive, or it seems to me that it would just be expected that children would engage with a better understanding of life.
Right.
So I hear on one hand that talking about this being intuitive, and on the other, it's just not intuitive.
Right. Well, it's intuitive in the sense that it's the children's intuitions, right? So this is in knowledge in 5-year-olds. So this isn't the kind of knowledge that you get by being explicitly instructed in school, for instance. So when we talk about an intuitive theory, what we mean is it's not something that comes from being explicitly instructed in a theory. The way that your guy's theory of biology presumably comes from having taken intro biology classes and having professors tell you this is how biology works. Whereas this is just coming from the children's spontaneous experience. Now, it's an interesting question about how much of that is the fact that in these communities, the natural world is very important. So adults are talking a lot about the natural world, and they're talking about things like how things die and how things live and die, and how much of it is that the children are actually seeing life and death unfolding in front of them and are drawing conclusions from that. And we don't really know what the answer to that is. Probably both things are happening. So they're hearing people talk about life and death more, and they're also seeing life and death more. My husband has a sort of sad story about growing up on his grandfather's farm in northern Colorado back in the 1950s, and he had a pet calf whose name was Hamburger, which would already have been a sign of what was going to happen. And there was a calf, and now he played with the calf, and the calf was there as part of the farm. And one day his grandfather said to him, "Okay, now it's time for us to eat Hamburger." And he went and got the calf and shot the calf in front of Albie. So I remember this as both this incredibly dramatic introduction to death in a way that very few urban children would actually have seen someone take out a gun and shoot an animal and watch the animal die. And also, of course, an introduction to the ecology of the farm, where an animal's called Hamburger because you're actually going to shoot it and turn it into hamburger and eat it. Now, in fact, in a really lovely experiment, one of my favorite experiments in cognitive development, you probably couldn't go out and show a bunch of children that you were shooting their pet calf on a regular basis. But there's actually an interesting natural experiment that even urban preschoolers experience about the nature of life and death, and that is goldfish. So anybody who's actually, there's there's a performance artist who did something called Life and Death Till Age 13, which was basically all about goldfish. And everybody who ever raises a goldfish has the experience of death. That just kind of goes with actually raising goldfish. And what Hatano Inagaki, the Japanese psychologist that I mentioned, did was they did a random controlled trial where they simply gave half of the children in a group goldfish to take care of, which is a nice, sweet thing to do. And then the other children didn't have goldfish, and then they tested them on their understanding of life and death a couple of months later. And what they discovered was that the children who had the goldfish did better, like the Indian children, did better in their understanding of life and death than the children who hadn't had the goldfish. So actually, even having just this little bit of experience of nature, these are children in urban Tokyo, just having a goldfish in a bowl was enough to give you experience that seemed to accelerate your understanding of life and death. I mentioned my son who was extremely anxious about death when he was about 7 years old. And when he actually went to write his college essay, he wrote this wonderful essay, very revealing to me about something I had not known, which was an essay of thanks to this goldfish. I can't remember what the name was, but it was thanks to the way that the experience of having this goldfish had cured him of his terrible existential angst about death, because this goldfish had died as much as he loved it, and he realized that life would continue to go on, that the world hadn't stopped, that death wasn't the end of everything, and he'd gotten this deep existential information from Oscar the goldfish. So it was called Thanks to Oscar was the name of his essay. Yep. They didn't. I don't think they recorded whether the goldfish actually died, but presumably, if you know anything about goldfish, there was a pretty good chance that a fair number of them died. But it didn't seem to be just about the goldfish time. Also, the fact you had to feed the goldfish because otherwise the goldfish would die. The fact that you saw the goldfish pooing after they got fed, that you had to change the water. All of that discussion about what you needed to do to keep the goldfish alive seemed to give the children this idea about biology. And I suspect also the fact that the goldfish, you couldn't really think of the goldfish as being like psychological beings very much. So life around goldfish is really pretty focused on its biological functions, not on things like its beliefs and desires. So it's not entirely true. I'm sure goldfish have some degree of mental life, but it's not something that's very vivid when you're taking care of them. Okay, so let's stop and have an explanation break here, and then we'll talk about other kinds of causality in play in a minute. So just explain to your neighbor how children's intuitive biology changes in the preschool period, something we just talked about.